Hello, I'm Telisha Middlebrooks.
And I'm Danielle Hawkins.
Today, the SOS team shines their science spotlight on AIM.
AIM stands for the Aeronomy of Ice in the Mesophere. We caught up with Hampton University's assistant professor, Dr. John McNabb, on what AIM is and why it matters to you.
AIM is studying the upper part of the atmosphere. Again, as I said earlier, AIM is looking at a region of the atmosphere that is right on the edge of space. And the atmosphere, we all live in the atmosphere, we have a lot of reason to wanting to understand the atmosphere, both in terms of understanding questions like climate change, questions about how our Earth interacts with the rest of the solar system, and how the rest of the solar system and the sun interacts with Earth. It also is important to understand the atmosphere in terms of understanding how life is affected and how the atmosphere is affected by life.
Alongside his graduate students, Dr. McNabb creates fun and practical science experiments. He believes that science can be fun too.
What we're going to do here now is we are going to look at some of the principles behind what makes a cloud and then do some cool things with that. There are basically three things that you need to form a cloud. You need something for the water vapor to nucleate around. You need the water vapor for the cloud, and you need cold temperatures. So our air is sufficiently dirty. There's plenty of stuff to nucleate around, even the stuff that you breathe every day. But what we've got here is we've got some warm water that's providing us with the water vapor. And now to make things cold, we're going to use some dry ice. Dry ice is frozen carbon dioxide. It's much colder than regular ice, hence the glove. All right, so now we've got some serious fog coming out of there. Let's see if we can get some serious, there we go. All right.
The primary goal of the AIM mission is to help scientists understand whether the clouds' ephemeral nature and their variation over time is related to Earth's changing climate. The AIM mission was launched in 2007 and has been extended by NASA through the end of the fall year of 2015. During this time, the instruments monitor noctilucent clouds to better understand the variability and possible connection to climate change.
The key point here is that the clouds in AIM need the same three things. They need water vapor, they need something to nucleate on, and they need cold temperatures. The clouds that we're looking at, polar mesospheric clouds, are actually at the coldest place on Earth. And the water vapor that gets up there through a mixture of dynamics. There's some water vapor that gets up there as a result of launching rockets. But it certainly, the water vapor that gets up there also gets up there naturally.
According to NASA, AIM is the first satellite mission dedicated to the study of noctilucent clouds. They are changing and scientists do not understand why. Studying noctilucent clouds will help scientists understand the future of our environment.